Hi guys and welcome to Learn Extra Live. It is Matt's Lit. Hayley is with us today.
Hi, Indy.
Hi Hayley.
Hi, guys.
Happy Valentine's Day.
Thanks to you.
Happy
You look
Valentine's
so wonderful with all your hearts around you.
I actually have a Valentine's Day present for you.
Oh,
She did it. You didn't know
Indy.
about
I didn't
this,
know.
didn't you? Are you surprised?
I'm totally
Here you
surprised.
go.
Thank you.
Happy Valentine's Day.
Thank you.
From
Thanks so much.
all of us at Mindset, as well as the Mindsetters. I'm just going to say it's from all of you guys. I'm not going to make you guys pay in or anything.
Thanks, guys. How should I go over?
Yeah,
You
yeah,
can do your
yeah.
thing.
Let me take it away. Okay, so guys, we are doing using graphs to solve problems. So please join us on www.facebook.com/learnextra and post those questions on the page. Big up to Macmillan for sponsoring the show. You guys rock, and we think you are awesome. Now, if you haven't heard me say this before, I'm starting to feel like I'm a bit of a broken record, but it's very, very important. This is the link you need to know, guys. This is where you're going to get our schedules. You can download the show notes as well as get previous week's videos. And you're going to be using this the entire year. This is the go-to spot for anything you really need mindset related. It's www.learnextra.co.za/live. I will post that on the page, not to worry. But what we need you guys to do is you need to post those questions on the page, because at the end of the day, there's no silly question, only the one that is asked after the exam, because then it is too late. So now I see Hayley's got a very awesome lesson for us. So I think we're going to go straight over.
Thanks, Indy. Hi, guys. Yeah, like Indy said, we're going to be doing using graphs to solve problems. We're basically continuing from our lesson of last week where we introduced graphs. So let's kind of see what we've got planned. So in this lesson, in this lesson, we're going to continue with making sense of graphs that tell a story and like graphs that we see in everyday life. We're going to look at constant difference relationships and constant ratio relationships, and I'm going to show you the difference between those two. And finally, we're going to look at step functions. So let's go right ahead and do that. So, as we discussed last week, and I've basically got this up here, we did it last week. I don't need to go into it in a lot of detail, but I'm going to just briefly read it to you. So it's a graph that tells a story. In fact, I'm not. So focus on me at the moment. You can read it in the notes. Your graph basically is set up very specifically. You've got your y-axis, that's your line going down. I always tell my kids in class, I'm going to draw this for a second, that y is this like long line. So that's your line going down, your horizontal line of your x-axis. Always remember your independent variable is on the x-axis and your dependent is on the y. And most often what I've experienced teaching Maths Lit over the years is that we're dealing with numbers or frequency on the y-axis or money. So very often those are the ones that we look out for. So those are dependent, independent. Let's move on to deal with this constant ratio. So what do I mean by constant difference ratio? In fact, if you remember the lesson from last week, we used constant difference. What this means is that as we're increasing, it was a direct proportion, as we're increasing our graph, as we're increasing our x variable, the y variable is going up at a constant rate. And I can't remember the values of last week, but I think we were dealing with kilometers and we were dealing with the amount of money. It went up at a specific amount. So a good example of this is simple interest. So let's take easy numbers. If I've got 100 Rand that I invest at, say, 10% per annum, 10% per annum, simple interest. So just with simple interest. That means at the end of year one, I have my 100 Rand. I have increased it by 10%, so I'm going to do 110%, and I'm going to end up with 110 Rand. Okay? Or let's work out, in fact, let's change that, make it a little bit easier. Let's not do that. Let's work out our percentage. Let me change our color here, and on the side we're going to say 100 Rand times 10%, and that gives me 10 Rand. So I'm going to be increasing this amount by 10 Rand every year. So after my first year, let's go back to my purple, I'm adding my 10 Rand. And that's where, whoops, not 11 Rand, 10 Rand. I'm adding my 10 Rand, so I get 110 Rand. Let's change colors for year two. So year two, I now have 110 Rand in the bank. I'm still adding 10 Rand, and I end up with 120 Rand. And can you see that it goes up at a constant rate? If I had to do year 3, let's just quickly do year 3. So we've now got 120 Rand in the bank, plus the 10 Rand, and we're now going to end up with 130 Rand. So all I'm doing every year is adding 10 Rand. It is a constant amount relationship, direct relationship and constant amount. Let's compare that now to our compound interest, which is in fact a constant ratio relationship. In a constant ratio, the graph, we are multiplying by a constant value. And usually that is by percentage. We're not adding or subtracting a value, but we are multiplying by that value. So let's take our example again of our 100 Rand at our 10% per annum. Right, so what do we have? In the first year, we take 100 Rand and we times by 110%, and we end up with 110 Rand. So that's the same. So that's year 1. Right, year 2, now I can't remember what color I use, we'll just use orange. I now have 110 Rand, and again I'm going to times it by 10%. So let's get our calculator out and see what that answer is. 110 times by 110%. And remember, I'm adding by 110% because I'm increasing it by percentage. And when I increase by percentage, I like to say it's 100 plus that percentage. But you can work out 10% of 110 and then add it. So that would be working in 2 steps. So get an answer to that, it's 121. So we have our orange, that's 121 Rand. In year 3, we're starting with 121 Rand, again times by my 10%, or increase it by 10%. And on my calculator, I've already got 121, so let's just times it by 110%. And I see that I end up with 133 Rand 10 cents. 133 Rand and 10 cents. Now remember, this is different to the one we had before. If you remember correctly, after 3 years, we had 130 Rand. So with compound interest, what happens is interest is being earned on interest. But now, very interestingly, what the graph would look like. Let's draw this graph. Okay, so let's just get out graph. I'll draw it. Let's draw it in green. We're going to draw the lines. So for my compound, my simple interest, it was just a straight line. Now my compound interest, let's do that in yellow, it's going to start off as a straight line and it's going to start increasing at a slight, like a slight curve. That's because, whoa, what happened to that? Where'd that line come from? Let's try that again. Okay, it's increasing slightly. And that is a constant ratio. So look out for those things. You're multiplying by a constant value. Hey, hope that helps. Let's move on to our step function. Our step function is something that I sometimes don't necessarily teach it. And when I was doing these notes, I was thinking, should I include it or shouldn't I? Because I think it is so logical. But I'm going to go through it now with you anyway, so I've decided it's probably the wiser thing to do. So our step function, they're special combination relationships where the parts do not connect to each other and they look like steps, therefore called a step function. So, for example, if I had to look at the parking fees in a shopping center, when last did you go shopping, Indy?
Sure. I don't know. Shopping, not in a while, but shopping centres, I've been there. I've been to shop today, actually.
Today. Okay, do you remember what you paid for parking? And normally it works like kind of a scale. So we get like,
it
kind
depends
of like
on where you go
let's
as well.
go 0 to 1 hour. Okay, and we're going to make that one free.
Yes.
And then if we've got 1 to 2 hours, and let's say
2 Rand.
2 Rand. Okay, and 2 to 3 hours is, let's say 4 Rand. And we carry on like that until it gets to a point where they say, well, for the whole day, it's a certain amount. Now, this is specifically a step. If I had to draw this as a graph, so let's change our color here and draw it as a graph. I have my time on my x-axis. So I'm going to go with 0, 1, 2, and 3. Then I have my amounts on the other axis. So let's put this in as 246. 246, I suppose I should put in the 0. Right, and now let's change colors to draw this. So from 0 to 1 hour, it was 0. From 1 to 2 hours, it was 2 rand. From 2 to 3 hours, it was 4 rand. And can you see how we've got this step occurring? Now, this is the one reason that I thought, well, I'm not sure if I should include it in the notes. Because in reality, this is one place where the graph is actually not that much easier to read than the table. So I think that if they had to put this up, imagine if we went to the parking lot and they had this graph for people to interpret and try to work out how much you're paying for parking. I think people will struggle a whole lot more than the town. So, and this is where we mean the unrelated, because from 0 to 1 hour it's a specific free, but from 1 hour and 1 minute or 1 hour and 1 second, you start paying the next price. It goes up in steps. Hey, that seemed like it's fair. I think we've got time to do my Valentine question.
Yes.
I think we've got time to do. Okay. I decided because it was Valentine's Day, I thought, now I have to actually do something with Valentine's Day. So I created this question. I don't think we're going to have time to finish it before we take a break, but let's start. I wish I had a red pen. Don't have a red pen. Okay. We've got 4 boys at King's School. They decided to buy roses for their girlfriends for Valentine's Day. They sat down before the time and each decided to buy 4 dozen roses. Clearly money was not an issue. So they each decided they're each going to buy 4 dozen roses. The table below shows the number of girlfriends each boy has and how many roses each girlfriend will receive. So let's work this out. Okay. If James has 1 girlfriend, how many roses is she going to receive? So, the focus of things says complete the table below. Above, I mean. So, James's girlfriend is going to receive all 4 dozen roses. So what we need to do is we need to work out how many roses that is. And clearly 4, there are 12 in a dozen. So she receives 48 roses. Lucky girl. So 48 roses for James's girlfriend. Peter, on the other hand, has 2 girlfriends. Now, how many roses is Peter's girlfriend going to receive? So we still have, he has 48 roses, and I'm going to find some space. Maybe I should move this up. No, that's not going to work. Let's move this a bit. Okay, let's go back to Peter. He has 48 roses that he is going to divide by 2 girls, and each one is going to receive 24 roses. So we've got 24. Then we've got Sipho. Now, Sipho can't really make up his mind, and he's decided, well, he's going to give roses to everybody, and he's got 4 girlfriends. So again, we're going to take Sipho's 48. Let's change our color here. So Sipho, he's got 48 roses, and there are 4 girlfriends, so each one is going to receive a dozen roses. And finally, we've got Kevin. Kevin gives each girlfriend 8 roses. Now, the question is, how many girlfriends has Kevin got? And he's definitely quite a player. So, Kevin, let's do Kevin above. We'll change our color here. What color haven't we used? Orange. So, Kevin's got 48 roses. Each girlfriend receives 8, and so he had 6 girlfriends. Now, I think we've worked out, we've done our table. But what I want to do is, before we go on to draw the graph, I want to actually discuss this table and what the numbers represent. So I'm going to try and delete that. Let's delete what we've got, don't have here, so it's a little bit clearer, and delete those 2. And I want us to look at the relationship in this graph. Now, I really don't know what color I haven't used, purple. So if you notice, the number of girlfriends is increasing, and the number of roses is decreasing. So we have here an inverse relationship graph. Well, an inverse relationship. We don't have a graph yet. So it is as the one is increasing, the other is decreasing. Now, what is important to note is that as we doubled that, we went from 1 to 2, what we did was we halved that. We went from 48 to 24. And we did the same thing. And it's quite easy to go back to the first one. So we times that by 4. Sorry, we divided that by, we times that by 4. And what we're going to do here is we're going to divide by 4. We're going to divide by 4 there. So we do the opposite. And that is what is called an inverse. But I think, you know what? Let's take a bit of a break now. We'll come back and draw the graph and we can discuss it a bit more.
Okay, let's do that. Let's take a little break. Go, it's really hot today. Go get yourself a glass of water, get something to eat. And before we do, talking about something to eat, these chips are making me really, really hungry. Simba, thankfully, has given us this awesome gift hamper, which we are giving away next week to one lucky mindsetter who posts a question, who posts a picture on our events page of them paying it forward and their random act of kindness. So I'll post the link up now. And guys, it's not about money. It's not about spending stuff. It's all about showing people you care. It's about doing the small things. It's about paying it forward. You never know what ripple effect you may create just by helping one person every day. Small things, helping somebody with their homework, carrying your mom's shopping in, helping somebody, with their trolley. Small things. See you now after the break. Hi guys, and welcome back to Maths Lit for grade 10s, 11s and 12. Proudly sponsored by Macmillan. Guys, please post your questions on the page. It's www.facebook.com/learnextra. Steffi says, Happy Valentine's Day, Hayley and
Thank
Indy.
you.
So happy Valentine's Day, Steffi, and your mom Liz, sending much, much love. Please post your Valentine's Day shout out on the page and they may get read out during the show. So now, on to Macmillan. I do know, Hayley, we were talking about during the break that the next question is actually
Out of the textbook.
out of the textbook, eh?
Absolutely.
Yeah.
It is.
And it's called, what is it called?
It's called
Everything Maths.
Solutions for All.
Solutions for All.
Can you give me a second? There you go.
There you
Solutions
go.
of all. Or for
Solutions-
all. Maths literacy.
Fantastic.
And I definitely use the textbook because it actually really is a nice textbook. And it's very user-friendly. And it's actually really nice. So that's where I get all my questions from. Well, not all of them. This one I tried to make up. Because Valentine's Day. Okay. Can I carry on?
Carry on.
Yeah, you told them all the websites they need. And everything.
They know everything.
Ah,
It's
that's
all up to you
perfect.
now
That's
to teach.
perfect.
And if they don't know anything, they can ask me on the Facebook page.
Absolutely, that's great. Okay, guys. So let's go back to our table. So as we've been discussing, the thing is this is an inverse relationship, an inverse proportion. Now, if I had to say another man, another boy, and let's say he had, and I can't now definitely have run out of colours. Okay, well, let's go back to green. Right. If he decided that he wants to give the roses to, like 1 rose to each person. So we're going to make this 1. We're going to add another little bit of our table. How many people will he give the roses to? How many ladies will he end up giving the roses to? So now, we can now look at it this way. What have we done from 48 to get to 1? We have divided by 48. So here I'm going to multiply by 48. So he can have 48 girlfriends, and each one is going to get 1 rose. At this point, we can't really go any further because I can't say, well, we're going to give them half a rose because I'm not sure that would work. So you've also got to think about what we're dealing with. So roses are a very specific, fixed number of roses. What I'd like to point out before I go on to the graph is that we can multiply these two. So 1 times 48, 48. 2 times 24 is 48. 4 times 12 is 48. So when you multiply the two numbers, you're going to end up with the same answer. And that's another thing that you can look out for. And in actual fact, that's how we did our calculations. So we divided each of these by 48. Right, let's now go and draw our graph. So first of all, on our graph, which one is our x-axis and which is our y-axis? Well, our first is always x and our second is always y. There's the number of girlfriends is what I can change, but then the result is how many roses they get. So my independent is the number of girlfriends, and the number of roses depends on how many girlfriends there are. So I'm going to put my number of girlfriends onto the x-axis. So my number of girlfriends I really need to go up to, I'm going to go up to 6. I don't think I need to go up to 48. So I'm going to go with 0. And I'm going to say that's 2. No, let's make that 1. Not thinking today. Okay. So we're going to draw this and make that 1, 2, 3, 4, 5, and 6. Right. So those were a number of girlfriends. And then our roses, we need to go up to 48. So I'm going to go up in 4s. So I'm going to go make that 4, 8, should put a 0 in, 12, 16, 20, 24, 28, 32, 36, 40, 44, and it fits perfectly, 48. Right, and now to draw the graph. So for one girlfriend, let's do it in orange. For one girlfriend, we had 48 roses, so we put a dot there. 2 girlfriends was 24. 4 girlfriends was 12. So find 12, find 4, join a dot, and 6 was 8. Right. And now we need to just join these dots. Now bear in mind that when you have a graph like this, where you've got the one going up and the other going down, it's going to be a curved graph and you can't use a ruler. So you need to really just do it with free hand, and I'm going to draw it, try get it accurate, and that's what the graph will look like. That's perfect. And then we can move on. So we will always have a curved graph. Right, let's move on to this question. Right, so we've got solutions for all. Maths Lit, grade 11, like I said. Topic 1, this is from page 6, and I guess we get a bit of a typo here, so let's just delete. Page. Does that delete it? Have I got a black? No, I don't think I've got a black.
Fine.
That's perfect. Page 6, question 2. So, the graph shows the number of casual assistants employed at a supermarket over a weekend. Oh, no, I don't want to use white. That's very boring. So no, not changing the color. Right. Over a weekend. So we're looking at one weekend and we're looking at the number of people employed. These are the kind of graphs that we're going to use to tell a story. And this is what we're going to look at now. So the calendar shows the school and public holidays for the same period shown on the graph. So first of all, we're going to look at our graph. So this is you spend weekend staffing from February to April. And it doesn't tell us which year. We've got the number of casual employees, and you can see that goes from 50 to 250, and we've got the weekends. Now, we're only looking at the weekends. So if I now look at this graph, February has got 4 weekends, right? And then March has 4 weekends, and April has 4 weekends. So we're looking at only the weekends. So it's important to actually understand the graph. And then we can see that our graph starts, well, we've got certain casual workers, and it's going up and down. Now, this is a dotted line. And in actual fact, in my last question, we probably should have had a dotted line. And that's because we don't have any values in between. There's no 1.5 weekends. It's either one weekend or the second weekend, but we don't have a value in between. So bear that in mind. This is what we call discrete data, which I think we discussed last week. Then we're looking at the weekends. February, like I said, 4 weekends. So what is special? The second weekend in February would be this weekend because it's Valentine's Day. We've got March, we've got 4 weekends. Then we've got, on the second one, we've got a school holiday. The third one, there's Human Rights Day, so it's a public holiday. In April, we've got the Easter weekend and Freedom Day, public holiday. So they've given us information about what's happening in those 3 months that we're looking at. So what period does this graph refer to? Quite easy. It actually tells you it's February to April. So just being able to, because we've interpreted the graph so well, we actually now can answer the questions really well. So which one does it refer to? It refers to February to April. How many casual workers were employed during the first weekend of February? So our first weekend of February, what we need to do is we need to take a line and we're going to draw it from our graph to the axis to read how many casual workers that is. And now we need to interpret that. So if you look at my graph, I have 0 and then 50, and I've got a line in between. So that line in between is 25, because then I goes up 75, 100. This is just below that line. Now I'm going to, what I tell my kids, guesstimate. It's not an exact number. It is not on the 25, it's less than 25. Is it 20? Is it 22? This is something that there's quite a bit of leeway when we mark this. So I'm going to go, well, it's close to 25. I'm going to go say 22 employees. So we can quite easily guesstimate that. Now I need a pen to write, not a line. So it was 22 casual employees. By looking at the graph, how can you tell that the number of casual workers employed was greater on the second weekend of February? So in what? How can we tell by looking at the graph? Well, from week 1 to week 2, we're looking at that space there. What happens to the graph? It increases. So we can see that it's increasing from week 1 to week 2, and that's how we can tell. So the graph increases from week 1 to week 2. So it's easy to see. And let's move on to the next part of our questions. Okay, look at our graph again. List the holidays in March. Now we're going to March, and we're now looking at the table, and we're seeing what holidays have we got. Well, in March, we've got school holiday, and we've got Human Rights Day. So we're going to list them, the school holiday. Now be careful with a question like this, and we had Human Rights Day. Because you might think to yourself, well, in actual fact, the only holiday, Human Rights Day, the only public holiday we have is Human Rights Day. But remember, they haven't asked you for public holidays, they've asked you for list the holidays. So I would definitely include the school holidays, because clearly it had an effect on our shop. So rather give more information than less. So because there are 2 holidays, I would add both of them. Explain how the holidays affected the number of casual workers employed each weekend in March. So now what we have to do is we have to see the second weekend was school holidays, the third weekend was Human Rights Day. How did that affect our graph? So we are looking at March. Let's give a little bit of space. We are looking at March. Let's change my color here. I think I need a yellow. And we're looking at the second and third week, the third weekends. And you can see that from 1 to 2 it increased. And then we had this like increase, that kind of steady increase from 2 to 3. Well, it went a little bit higher in 3. So what can we say about this? And then it went down in week 4. So what can we say about it? How did it affect it? It affected the number of casual. We needed more casual workers, more workers when there were holidays. When there were holidays, my handwriting is really not great, Indy. Holidays in week 2 and 3. And that's how it affected. And we can see this because the graph is increased. Then finally, by looking at the graph, how can you tell that the store is busiest during the school holidays? Right, now we go back to find where our school holidays are. And busiest during school holidays. Okay, because during school holidays, we have an increase in the number of employees that are needed. Now you're going to employ more employees, you're going to have more employees if your store is busier. So your casual workers, so because we have more casual workers in school holidays, means the store is busier. So we have more workers. And remember, these are casual workers. So these are workers that are basically employed on the day to just come in for the weekend. So more workers because the store is busier. So the shop needs more people if it is busier. And let's move on. Okay. Next question says, For the period February to April, which weekend was the busiest? So we're going to go back to our graph and we're going to see, well, where were we busiest in this graph? And what I like to do is take your ruler. I don't know if I've got a ruler. We'll do it with a one. And let's draw a line right across. Okay? And now we're going to take this line, and I'm going to move it up. And I basically want to see where is the most employees, the most casual employees. And now I've got to the point where there's the most casual employees. And now I'm going to take a line and I'm going to draw a line down from there and see which weekend it was. Well, it was weekend. Okay, that didn't work. So move that over a little bit. Let's undo that. Let's try that again. Okay, let's delete that. Okay, try that again. See if I can get a straight line this time. So we're doing a down, down. And you can see that it is week 2 in April. That is our busiest time of the shop because that's when we needed the most casual workers. So let's say which period? It was April week 2. And why do you think that was the busiest weekend? Well, let's see what happened in week 2. So we're going to go back to our table. What happened? It was the Easter weekend. So clearly everybody was shopping. So it was the Easter weekend. And remember about the Easter weekend is that you've got Friday and Sunday, Friday and Monday. I'm trying to get my days right. Friday and Monday off. So you've got a 4-day weekend. So in actual fact, you've got more time to shop. What is the relationship between the holidays and the number of casual staff hired? Well, that's quite easy. We actually discussed it earlier when we were talking about busier. So the holidays, on holidays, we need more staff. So holidays basically means more staff. And kind of the bigger the holiday is, the more staff that we need. I think that that's the end of that question. So I'm going to leave it there at that last question. Have I answered everything? Yes, I have. I'm going to send you for another break because I think that we really need like a little bit of a breather.
A little breather. Okay. I think that's a good idea. Okay, guys, I just want to say that a lot of you are posting your random acts of kindness on our Facebook events page. But you know what started happening? We said to everyone, post your pictures and your videos. But what's happened is a lot of mindsets to actually post things that they've been doing, and it's small ways where they've been, doing random acts of kindness. So Takalani says, helping my friends and schoolmates on how to get connected with Mindset Learn Extra via Facebook and on TV. That rocks, Takalani. Thank you. But he also says, as a grade 12 learner, I'm sharing my study guides with classmates so they can also ace it at the end of the year, which I think is so amazing. So it's just that, it's that tiny little thing, paying it forward. Takalani sharing his textbooks with other grade 12s. What are you guys doing? Post on our page, and we'll see you now after the break. Hi guys and welcome back. I hope that you're all enjoying the show. The page is far too quiet. If you have any questions for Hayley, now is the time to send them. It's facebook.com/learn extra. You can also chat to me, Indy, on Twitter @learn extra. I'm just assuming that it's Valentine's Day, so you guys are all out and about and not watching Maths Lit. guys. Okay, so now I know I was telling you about Macmillan and their books earlier. So this is Solutions for All. So now I can actually show you the book and where it comes from. So this is where we get our content and some of our questions that Hayley is going over, and as well as the notes. If you've downloaded those notes from our website, then some of the content is from there. So now, random acts of kindness again, because it is Valentine's Day. It's all about spreading the love and showing people you care, not in big ways. It's not about money, guys. It's about the small things. It's about creating that ripple effect. You know, you help someone, and that someone goes, "Oh, I think I'm going to help the next person," and then before you know it, it's spread like wildfire. But all it is, it's about people caring and sharing and loving each other. So now, if you post your random acts of kindness onto our events page, you can actually win this awesome hamper from Simba and these awesome Cheetos chips. There's literally like They're huge, and this awesome mindset T-shirt. We've got lanyards, we've got packets of chips, as well as 5 CDs, guys. 5 CDs. I mean, how much is a CD these days? 140 rand.
Yeah, it's a
So it's at
huge
least
price.
like 600. Maybe I can get Haley to do the working out. How much are these worth? We've got the Unati with Love CD. I love Unati. We've got Donald's Train of Love. We've got Kaya for You. We've got Malik, Music of Love. And then we've got the one and only Love Songs album you will ever need. And this is 3 CDs. So it's actually like 6, 7, 8 CDs. That's
Wow.
ridiculous. And it's all
And
about
it's Valentine's
love.
Day today.
It's
so
Valentine's Day. And
really,
it's all
the
about,
love song's
this is the
great.
month of love. And it's about paying it forward. Doing things for people that are small things. They really are. They're not big things. I just want to read one quick thing from Mosa. She's just done really small things that help mindset. So she says, there's this little well-behaved girl at my school, and she's in grade 9. You can see that she's from a poor background, so she doesn't have many friends at school. I get touched every time I see her walking alone during breaks, so I say hi to her. I ask her questions on her schoolwork and make jokes so that I can see the smile on her face. So now we're great friends, and sometimes when she needs something, she can come straight to my class. She doesn't have a Casio calculator, so she won a Casio calculator here on Mindset Learn last year, and she decided to give her the one that she was using so she can have, because she's got the one that she won. I gave her the calculator last week on the 7th of February, and this is how I showed my love and care this month. And that, guys, is what it really is about. Paying it forward in the smallest little ways. But now I'm not going to take away any more time from this all-important Mathslit lesson. Please send those questions in, because Haley and I are going over them in the last few minutes of the show. I think we literally, because I've been talking so much, have 13 minutes left to the show. Right, Haley?
Thanks, Indy. Absolutely. Your time's good. Okay, guys. So welcome back. So we've done this question. Let's move on now to a question. This is okay, question 3. It's adapted from the NCS. I don't have a pen. Let's get a pen. It's adapted from the NCS, the Eastern Cape, September 2012, paper 2. This is from their prelim paper, and it is question 3. So if you do have a copy of the Eastern Cape paper, then you can follow it on question 3. But this is in the notes, and it's important that you, it would be nice for them to download the notes before the lesson, then they've got everything.
Exactly.
Right. And what I really liked about this question is I loved this graph. So the graph below shows Shamiza's monthly repayments over a period of 20 years. We are dealing with a bond. So the question kind of leading into this graph was that she was taking out a bond, and she had, I think it was like 1.2 million that she needed to spend on the house. And now we got into the point that we're looking at her repayments. So study the graph below and answer the questions that follow. So before we answer the questions, I really want to look at this graph. And I wish I had this in color, but you wouldn't have got it in color either in your paper. So we're going to do it like this. Our loan amount, in fact, let's try to highlight it. Our loan amount that she had is this white, no, that's not working, not too much. So let's delete that. Right, our loan amount is this is the white part. That's the loan that she's repaying. The interest is the darker parts. So we've got our loan in green. Let's get some green. So our loan, so in 2011, she pays that much off the loan. That's off the capital. And she pays the balance. Let's change the color of that. The balance she is paying in interest. So that's basically what's happening. In 2013, which is like 2 years later, she's paying a little bit more of her original loan. So more goes towards the loan, and there's less interest. And if we look at this graph, it really is an interesting graph, because every year she is paying a little bit more of the loan. A little bit more of the money goes in. You can see that her payments are constant every month or every year. She's paying a certain amount into the bond every single year. But how that money is kind of split up. In the beginning, she's paying towards interest, and towards the end, she's paying less interest and more of the original loan. And this white line going down here is actually the balance in her account. That's the balance of the loan owing. So it really is a stunning graph. And you can see that it goes over 20 years. So we've got from 2011 to 2031. just, they've only labeled every second one, and that's basically what the graph is. Really a nice graph. And what I love about the subject, I really love about the subject, is it shows you so many things that are relevant and so many things that are important, because hopefully one day you guys are going to go out there and you're going to be buying homes and you're going to be applying for bonds and you're going to be repaying these over 20 years. Now you can understand what happens to your bond and what happens to your payments. Now, what is a nice point to make, so I'm going to actually add this at this point, is that if you pay a little bit more at the beginning, let's just see if we can do this. Let's get it out. If you make your payment a little bit higher, what ends up happening is you pay more of the loan, because that portion, in fact, let's not put it there. Let's move it. It will be at the bottom. We're kind of going to put this there. You're going to end up with a bigger portion coming off your loan, your original actual that you borrowed from the bank, and you will end up paying less interest. You're going to save yourself a fortune in interest, and you're going to possibly save a fortune in years. So try to remember this for one day when you go buy your house. Try to put a little bit extra into your bond every month. It does make a difference. Okay, let's carry on with our question though. So, on what will Shamiz pay off the greatest part of her monthly repayments in the first 10 years? And why do you think this is the case? So, first 10 years, we said she is paying more interest. That is what she's paying. I can't spell today. Right. She is paying interest. For the first 10 years, she's paying more towards interest. And why do we think that? That is because our loan amount is huge. So our loan amount is big. So the larger our actual loan amount is, the more interest we're going to be paying. So that's the first few years. Then it says, on what will Shamiz pay off the greatest part of her monthly repayment in the loan in the last 10 years? So our last 10 years, that's basically from here, she's paying more of the loan than she is the interest. So she's actually paying more in loan. So this is going to be the loan. And why do you think this is the case? This is because our underlying capital owed is less. So our capital amount has decreased. So remember that your interest is calculated on how much you owe the bank. So on your actual capital amount. So in the beginning we pay a lot of interest because it's a huge amount, and as this amount gets smaller, the amount of interest we have to pay is lower and we eat more into the capital. Alright, let's move on to the next part of the question. During which year will Shamiz pay approximately the same amount of her monthly repayment to both the interest and the loan? Okay, we've got another little bit of a gremlin in the works. We'll just leave it there. So this is repayment on. And now what we're looking for is we're looking for one where our white and our black are about the same. And I'd probably say that if I had to do this as a, I'll tell you what we can do. Let's delete that. Let's draw a line. I think it's probably there. And what I'm going to do is I'm going to move that. Okay, let me change this color. Let's undo that. Let's change that to this green. So I'm going to draw a line on my white. Now, you've got a ruler. It'll be a whole lot easier to do with a ruler. Let's click that up and see how it fits there. That's close. That's close to the same. Okay, we can do the same thing. Let's try the same thing again with the second one. So dotted line. Right, and let's now pick that up and move it. No, don't want to do that. Just going to move it. So at that point, whoops, that's definitely not moving. Got a mind of its own. Okay, so it's somewhere between 2021. So what year is that? It's after about 10 years. So that they're both the same. So it's about 10 years. And remember, this is like an estimation system which we're approximately the same, so it's about 10 years. They don't want an exact value. So we want the two the same. And then finally, why do you think it takes 20 to 30 years to pay off a home loan while it only takes 5 or 6 years to pay off a car? And this is a nice question. It really is a nice question. It comes out of your paper too. It's a thinking level 4 question because, guys, this is your opinion. And it's very hard for me as a teacher to actually mark it wrong. In fact, I tell my kids in class, Indy, that my memo usually says any valid answer. And I love that. Any valid answer. Because honestly, it is your opinion. So if I had to ask Indy now what she thought, she's going to give me an opinion.
Can I?
Go ahead.
Okay.
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 Why is it 20
This is
to
what
30 years?
my answer would be. I would say because a house is so much more expensive than a car. Why do you think it takes 20 to 30 years to pay off a home loan?
So a house is
Yeah,
more
it's more
expensive. That's a
expensive.
very valid question.
Would
So
I get full marks for that?
You would have got your marks for that.
Oh,
So a
sure.
house is much more expensive. A house is more expensive. Okay? And then we've also got to think, what about my car? How many 20-year-old cars do you know driving around?
I know a few, but then obviously they've depreciated.
They've
in value.
depreciated.
Yeah.
And usually after 10 years, your car kind of like conks in. Okay?
Yeah.
And that's why people normally keep their cars for about 5 or 6 years. And then they have to get new cars. And that's because of motor plans and all these things that go into it. So that could be another reason why you wouldn't take out the loan. Because you're not going to take out a loan for 20 years for a car where after 5 years you need to get a new car. And then you're still paying for the car that you had.
So it's kind of like also like a cell phone. You take, like contracts out for 2 years because, I mean, cell phones only last about a year or 6 months anyway.
Absolutely.
It's the same kind of thing.
Absolutely, absolutely. So it's, and if we had shorter contracts, we probably would take out shorter contracts if we could.
I think so because the
They
phones only
t-
last
phone-
6 months
Absolutely.
anyway.
So those are your reasons. And honestly, these are things where you can give your opinion. So think about it and try to think outside the box. I get such wonderful questions. That's why I love these questions. I get such wonderful answers.
It's awesome.
Indeed, there was a question that somebody had about.
Yes,
I'll
let me
find some more
see.
space. And then if I've got another page, let me see if I've got another page.
From Zaziwe. Zaziwe says, hello, how do I find the break-even point?
Okay.
Can we go over this in today's lesson?
Let me see if I've got time, and I think I do. How much time have I got?
I think you've got 3 minutes
Have I
or
got
so.
3
Yeah,
minutes?
we can do it.
Okay, I'm sure we can do that. So, but I'm not going to get the name right. So tell me that again. It was
Zazizwe.
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 That's about break-even point. Now, I think last week I had a break-even point, but if you missed the show, I'm going to go over it again, and I'm going to give you the information. So your break-even point basically deals with 2 graphs where you've got 2 relationships on the same set of axes. Very often with break-even point, we are dealing with income and expense. So we are comparing a shop or a little business where we've got a certain amount of income and a certain amount of expense. So our income is kind of set at a fixed rate. So we've got it goes up at a certain rate. So let's look at a graph. And in fact, I wonder what happens if I change this color. Will it change? Yay. Okay, we'll do blue for income and green for expense. So my income, I start with. If I've got nothing, I'm not selling anything, so if I start at 0, I'm not going to make any money. And we've got money here, and we've got the number of kind of things there. So my graph is going to be a straight line. That's going to be my income. My expenses, on the other hand, are going to start. Normally, we have a fixed expense for things like rent or salaries, and we then have a straight line going up from there. Okay, also a fixed cost, and this is a constant amount increase, like we discussed at the beginning of the show. Now, this point here is your break-even point. That is where my income is equal to my expense. And where they break even at this point, we can read that value. If we get a graph, we can read that value off the table there to get the number of things, and we can read it off the y-axis to get the rand value for that. Now, if you need to do this on a graph, that's the way you would do it. And as an equation, you can make the 2 graphs equal each other, the 2 equations equal to each other. So I hope that helps. And on that point, I think I'm going to hand you over to Indy. I'm going to say goodbye, guys. And I think that's enough of graphs. Next week, I think we do something like measurements or something.
Yeah.
It'll be fun, though. So
You better
join us next
tune
week.
in. You better tune in. And what you can do is you can go to the schedules, and schedules are www.learnextra.co.za/live. Thank you so much, grade 10s, 11s,
Happy
and 12s.
Valentine's Day.
Have a fantastic Valentine's Day. Big up to Macmillan for making this show possible. You guys rock. And have such a lovely day, mindsetters. And don't forget, pay it forward. See you same time, same place next week.